Worked example 17, RL phasor diagram. In a RL circuit with a supply voltage of 420 volts, resistance of 30 ohms and inductive reactance or reactance of 21 ohms, there is a phase shift of 35 degrees and the supply current is 6.55 amps. Part A, sketch the phasor diagram for the circuit. Right, in order to get started with this, to draw the phasor diagram, we need a few other bits of information that we'll have to calculate first of all. And those are the voltage drops over each of these components, VR and VL. And when it comes to drawing the phasor diagram, what I would always remember is that for an RL diagram, it should always look a bit like this, where my VL points directly upwards, my VR will be in phase with my supply current, and my VS will be somewhere up here at an angle of theta. Let's calculate the voltage over the resistor, voltage over the inductor. So VR is going to be my supply current multiplied by my resistance. In this case, I'm given my supply current of 6.55 and my resistance is 30 ohms. And that gives me a voltage drop over the resistor of 196 volts. VL is going to be my supply current times XL. So in this case, 6.55 times my reactance here of 21, which gives me a voltage drop of 137.6 volts. With those two voltages now, I have all the information I need to start sketching the phasor diagram. So as a reminder, phasor diagrams should only ever have voltages and currents. Those are the only values that should be on there. What I'm going to do now is draw out the four phasors that I will be actually sketching onto the phasor diagram. VR is 196 volts at an angle of 0 degrees. VL is going to be 137.6 volts at an angle of 90 degrees. VS, my supply voltage, is going to be the 240 volts at an angle of the theta that we're given in the question, 35 degrees. And finally, the last phasor that I need to draw here is my supply current, which is going to be a 6.55 amps, and that is going to be at 0 degrees. And the reason the supply current is at 0 is because we're taking the supply current as reference in this case. To draw my phasor diagram, I'm going to have to draw all these phasors, these vectors effectively, to scale. And that means I need to pick something that I can fit on the page that's going to make sense. And in the book, I've gone with a scale of 1 centimeter equals 20 volts, and 1 centimeter equals 1 amp. So the two scales, one scale for voltage and one scale here for current. So the easiest thing to do now is to look at each of these and then divide them by my scale, so 20 in this case, and that'll give me the length, and then that means I know the length I need to draw my phasors at. Now that I've got the four lengths of the lines that I need to draw, I can come over here and start to sketch it out. So I know the longest line I've got to draw is 12 centimeters, so I need at least 12 centimeters of space for that. My VR is going to be 9.8 centimeters along the axis here. My VL is going to be 90 degrees, which is straight up the way, and that is going to be 6.88 centimeters. Now, obviously, there's a limit to how accurate you can be, so just be as accurate as you can. So I've gone to 6.8 centimeters for that one. VS. Now, there's a little trick to this. If you don't have a protractor, which you should have, but if you've forgotten it, the little trick is you can just draw a vertical line coming off of the end of VR, very faintly. Draw a horizontal line coming off the end of VL, nice and faintly. And where those two cross is where you should be drawing your VS to. And to demonstrate that, I'll actually measure the angle in just a second to show you that it's 35 degrees. And the length is 12 centimeters. So to start with, is it 12 centimeters? that's pretty close. That looks pretty good to me, is 12 centimeters. And for the angle, so we're aiming for 35 degrees, and I'm sure I've zoomed in the video here, but we can see 35 degrees. So that's a little it's a little hack, I suppose you might call it. Just remember that if you do forget your protractor, or you don't have a protractor, where the horizontal and the vertical lines intersect, that is where your VS is. So we can label that VS. Don't draw these lines too thick, just maybe even do it in pencil so you can take them out, because they're not part of the phasor diagram. They're there just to give you an indication of where VS finishes. So just to make sure it's clear. And finally, the last vector we need to draw to scale is our supply current, which is 6.55 centimeters at an angle of 0. So we've got 6.55 roughly there. And again, we could offset that a little bit just to make it clear. And there is our IS. Hopefully that was helpful. If you need a bit more information on how to draw phasor diagrams, I do have a separate video. I'll put the link on the screen now and in the comments, and that takes you through how to actually sketch phasor diagrams in a lot more detail.